Venus, the second planet from the Sun, and the sixth largest planet. It's the hottest planet in our solar system. Venus is a cloud-swaddled planet and our nearest planetary neighbor. It has a surface hot enough to melt lead. Venus is a hostile and extreme planet, the hottest in the solar system. It shines so brightly in the sky that we mistakenly call it the morning or evening star. Venus and Earth share similarities in their masses, sizes, densities, and relative locations in the solar system. Since they were presumably formed in the solar nebula from the same kind of rocky planetary building blocks, they also likely have similar overall chemical compositions. For these similarities, Venus has been called Earth's twin. Venus orbits the Sun at a mean distance of 108 million kilometers, 67 million miles, which is about 0.7 times Earth's distance from the Sun. When viewed through a telescope, Venus presents a brilliant yellow-white and a featureless face to the observer. Its obscured appearance results from the surface being hidden from sight by a continuous and permanent cover of clouds that are difficult to view in visible light. Venus's mean radius is 6,051.8 kilometers, 3,760.4 miles, or about 95% of Earth's at the equator, while its mass is 4.87 times 1,024 kilograms, or 81.5% that of Earth. Venus has the most massive atmosphere of all the terrestrial planets. Its gaseous envelope is composed of more than 96% carbon dioxide and 3.5% molecular nitrogen. Trace amounts of other gases are present, including carbon monoxide, sulfur dioxide, water vapor, argon, and helium. Venus is the second planet from the Sun. Similar in size and mass to Earth, Venus has no liquid water, and its atmosphere is far thicker and denser than that of any other rocky body in the solar system. The atmosphere is composed mostly of carbon dioxide and has a thick cloud layer of sulfuric acid that spans the whole planet. At the mean surface level, the atmosphere reaches a temperature of 737 K and a pressure 92 times greater than Earth's at sea level, turning the lowest layer of the atmosphere into a supercritical fluid. From Earth, Venus is visible as a star-like point of light, appearing brighter than any other natural point of light in the sky, as either the brightest morning star or evening star. Venus orbits closer to the Sun than the Earth does. The orbits of Venus and Earth make the two planets approach each other in synodic periods of 1.6 years. In the course of this, Venus comes closer to Earth than any other planet. In interplanetary spaceflight from Earth, Venus is frequently used as a waypoint for gravity assists, offering a faster and more economical route. Venus has no moons and a very slow retrograde rotation about its axis, a result of competing forces of solar tidal locking and differential heating of Venus's massive atmosphere. As a result, a Venusian day is 116.75 Earth days long, about half a Venusian solar year, which is 224.7 Earth days long. Venus has a weak magnetosphere, lacking an internal dynamo. It is induced by the solar wind interacting with the atmosphere. Internally, Venus has a core, a mantle, and a crust. Internal heat escapes through active volcanism, resulting in resurfacing, instead of plate tectonics. Venus may have had liquid surface water early in its history with a habitable environment, before a runaway greenhouse effect evaporated any water and turned Venus into its present state. There are atmospheric conditions at cloud layer altitudes that are the most similar ones to Earth in the solar system and have been identified as possibly favorable for life on Venus, with potential biomarkers found in 2020, spurring new research and missions to Venus. Throughout history, humans across the globe have observed Venus, and it has acquired particular importance in many cultures. With telescopes, the phases of Venus became discernible and, by 1613, were presented as decisive evidence disproving the then dominant geocentric model and supporting the heliocentric model. Venus was visited for the first time in 1961 by Venera 1, which flew past the planet, achieving the first interplanetary space flight. The first data from Venus were returned during the second interplanetary mission, Mariner 2, in 1962. In 1967, the first interplanetary impactor, Venera 4, reached Venus, followed by the lander Venera 7 in 1970. As of 2025, Solar Orbiter is on its way to fly by Venus in 2026, and the next mission planned to launch to Venus is the Venus Life Finder, scheduled for 2026 as well. Venus is one of the most studied and yet still deeply mysterious planets in the solar system. From the earliest human civilizations that watched it glow in the dawn and dusk skies, to modern spacecraft that have attempted to probe beneath its thick clouds, Venus has always drawn attention for its striking brightness and strange behavior. Although it is often called Earth's twin because of its similar size, mass, and rocky composition, the reality of Venus is that it represents a dramatically different evolutionary path. It is a world shaped by extreme heat, crushing atmospheric pressure, and a dense carbon dioxide atmosphere that has transformed it into the hottest planet in the solar system. Yet behind this hostile exterior lies a long and complex history that continues to challenge scientific understanding and expand what humanity knows about planetary formation, climate evolution, and the possibilities of habitability in the universe. The story of Venus begins long before human observation, in the early formation of the solar system around 4.6 billion years ago. Like Earth and the other terrestrial planets, Venus formed from the accumulation of dust and gas in the protoplanetary disk surrounding the young Sun. Over time, gravitational forces pulled these materials together, forming larger and larger bodies until Venus emerged as a distinct planet. In its early stages, it is believed that Venus may have been much more similar to Earth than it is today. Some scientific models suggest that it could have had a thinner atmosphere and possibly even liquid water on its surface. If this is true, Venus may have once been capable of supporting conditions that were not entirely unlike those on early Earth. However, the path it followed diverged significantly due to a combination of solar radiation, atmospheric chemistry, and geological processes that gradually transformed it into its current extreme state. As Venus evolved, its position closer to the Sun played a critical role in shaping its environment. Receiving nearly twice the solar energy that Earth does, Venus was subjected to intense heating from the early stages of its history. If liquid water existed on its surface, this increased radiation would have caused it to evaporate over time. Water vapor is a powerful greenhouse gas, and as more water entered the atmosphere, it would have trapped more heat, leading to further evaporation. This feedback loop, known as a runaway greenhouse effect, is believed to be one of the key processes that drove Venus toward its present condition. Over time, the planet likely lost its oceans entirely, leaving behind a thick atmosphere dominated by carbon dioxide. Once Venus lost its water, its climate regulation system effectively collapsed. On Earth, oceans play a crucial role in stabilizing temperature by absorbing carbon dioxide and distributing heat. Without this mechanism, carbon dioxide accumulated in the atmosphere of Venus, creating a dense insulating layer that trapped heat and caused surface temperatures to rise dramatically. Eventually, the planet reached a state of thermal equilibrium where the surface became hot enough to melt lead. Today, average surface temperatures on Venus remain around 465 degrees Celsius, a level that is consistent across the planet regardless of day or night due to the thick atmosphere's ability to distribute heat. The atmosphere of Venus is one of its most defining and extreme features. Composed primarily of carbon dioxide with clouds of sulfuric acid, it creates conditions unlike anything found on Earth. The atmospheric pressure at the surface is about 92 times greater than that of Earth, which is roughly equivalent to the pressure found deep beneath Earth's oceans. If a human were somehow able to stand on the surface of Venus, they would be crushed almost instantly by this immense pressure, long before the heat became fatal. The atmosphere is also highly dynamic, with winds in the upper layers reaching speeds of hundreds of kilometers per hour. These winds create a phenomenon known as superrotation, where the atmosphere circles the planet much faster than the planet itself rotates. One of the most unusual aspects of Venus is its rotation. Unlike most planets in the solar system, Venus rotates in the opposite direction, a motion known as retrograde rotation. This means that on Venus, the Sun would rise in the west and set in the east. Even more remarkable is the extremely slow speed of this rotation. A single day on Venus, measured as one full rotation relative to the stars, takes about 243 Earth days, which is longer than its entire year of 225 Earth days. This unusual combination of slow and reversed rotation remains one of the mysteries of planetary science. Some theories suggest that massive collisions in the early solar system may have altered its spin, while others propose long-term atmospheric interactions as a contributing factor. Beneath its dense atmosphere, Venus has a solid rocky surface that shares similarities with Earth in terms of composition. It is believed to have a crust made of silicate rock, a thick mantle, and an iron-rich core. However, unlike Earth, Venus does not appear to have active plate tectonics in the same form. Instead of large moving plates that recycle the crust, Venus may experience a more uniform or episodic style of geological activity. This has led scientists to propose that the planet undergoes periodic resurfacing events, where large-scale volcanic activity covers vast areas of the planet in relatively short geological time scales. Radar mapping missions have revealed that the surface of Venus is dominated by volcanic plains, vast lava flows, and large volcanic structures. These features suggest that volcanic activity has played a major role in shaping the planet's surface. Some regions, known as tesserae, appear highly deformed and may represent some of the oldest surfaces on the planet. These areas show evidence of intense tectonic stress, suggesting that Venus may have experienced significant internal changes in its past. Whether the planet is still geologically active today remains an open question, although some thermal observations suggest that volcanic activity may still occur in certain regions. The study of Venus's surface and atmosphere has been greatly advanced by space exploration. Early observations from Earth were limited by the thick cloud cover, which completely obscures the surface in visible light. It was not until radar technology was used in space missions that scientists were able to map the planet in detail. Missions such as NASA's Magellan spacecraft provided high-resolution radar images that transformed understanding of Venus's geology. Earlier Soviet missions in the Venera program achieved the first and only direct landings on the surface of Venus, transmitting data for short periods before succumbing to the extreme conditions. These missions revealed critical information about Venus's environment, confirming its extreme heat, high pressure, and chemically reactive atmosphere. Despite their brief duration, the Venera landers provided some of the most valuable direct measurements of any planet in the solar system. Later missions focused on orbital studies, using radar and infrared instruments to further investigate surface features and atmospheric dynamics. The distance between Earth and Venus varies significantly depending on their positions in orbit. At their closest approach, the two planets can be separated by approximately 38 to 40 million kilometers. At their farthest, when they are on opposite sides of the Sun, this distance can exceed 250 million kilometers. On average, the distance between Earth and Venus is around 170 million kilometers. These variations are important for space exploration, as they determine when missions can be launched efficiently. Despite being one of Earth's nearest planetary neighbors, Venus is not always easy to reach due to orbital mechanics and alignment constraints. From Earth, Venus appears as one of the brightest objects in the sky, often visible shortly after sunset or before sunrise. Its high reflectivity is due to the thick cloud layer that surrounds it, which reflects most of the sunlight that reaches the planet. This brightness has made Venus an important object in human culture for thousands of years. Ancient civilizations observed its motion carefully, often interpreting it as two separate celestial objects before realizing it was a single planet. It has been associated with mythology, symbolism, and early astronomy across many cultures. In modern science, Venus plays a crucial role in understanding planetary evolution. It serves as a natural example of how similar planets can evolve in dramatically different ways. Despite being similar in size and composition to Earth, Venus has become a hostile world incapable of supporting life as we know it. This contrast highlights the importance of atmospheric composition, solar distance, and geological activity in determining planetary habitability. The concept of habitability is central to the study of Venus. Scientists believe that the planet may have once been habitable billions of years ago, potentially with oceans and moderate temperatures. If this was the case, Venus may have remained in a habitable state for a significant period before undergoing runaway greenhouse warming. The loss of water would have marked a critical turning point, as it removed the planet's ability to regulate carbon dioxide through natural cycles. This transformation provides a powerful example of how planetary environments can change over time. Venus also plays an important role in the study of exoplanets. Many planets discovered outside the solar system fall into size and temperature ranges similar to Venus. These so-called Venus-like planets are likely to have thick atmospheres and extreme surface conditions, making them poor candidates for life. However, studying Venus helps scientists refine models used to assess habitability and interpret data from distant worlds. It serves as a benchmark for understanding what makes a planet Earth-like or Venus-like in evolutionary terms. The atmosphere of Venus continues to be a subject of intense study due to its complex chemistry and dynamic behavior. The clouds contain sulfuric acid droplets and trace gases that interact in ways not fully understood. Some chemical anomalies detected in the atmosphere have sparked debate about their origin, although most explanations involve non-biological processes. The upper cloud layers, where conditions are less extreme, have even led to speculative discussions about whether microbial life could exist in such environments, although no evidence currently supports this idea. Technological innovation is increasingly focused on overcoming the challenges of exploring Venus. Future missions may use advanced materials capable of withstanding extreme temperatures, as well as autonomous systems that can operate in harsh conditions. Concepts such as high-altitude balloons and atmospheric probes are being developed to study the planet without requiring surface survival. These approaches may allow for long-duration exploration of Venus's upper atmosphere, where conditions are more stable compared to the surface. Venus also serves as a key reference point in understanding Earth's future climate. By studying how Venus became a runaway greenhouse world, scientists gain insight into the limits of Earth's climate stability. This knowledge is increasingly important in the context of global climate change, as it helps identify thresholds beyond which planetary climates may become unstable. In conclusion, Venus is a planet of extremes, contradictions, and scientific importance. It is both Earth's closest planetary neighbor and one of the most hostile environments in the solar system. Its history likely includes a transition from potentially habitable conditions to its current state of extreme heat and atmospheric pressure. Despite decades of study, Venus continues to challenge scientific understanding and inspire new questions about planetary evolution, climate dynamics, and the nature of habitability. As exploration continues, Venus will remain a central focus of planetary science, offering valuable insights not only into its own past and present, but also into the future of Earth and the broader diversity of worlds in the universe. Thank you for watching this video.